and the recording will be also available on the channel. And let us begin. If we don't finish today, we will definitely have to finish on Friday. So I'll take that Friday class to wrap up, and then I'll cancel other group because I have a clash on Friday. That's why I had cancelled my classes for Friday. But if we don't finish the classes on, so that at least by next week you are all ready to write. So we have a bunch of formulas here, and on these formulas we have what? On these formulas we have mean number of arrivals per time, number of arrivals per time, 10 minutes per hour, 10 cars per hour, number of arrivals per time. Mean, this one is mean number of people or items saved per time. How many customers we are saving per time? It's always product per time, item per time, person per time. Right. So those two variables are very critical for you to understand. So now, this is queuing theory, ne? And even though it doesn't have theory, but it's queuing theory. So when determining the arrival rate and the service rate, the same time period must be used. The same time period, meaning what? They are referring to the SI unit. The same SI unit applies. Yeah? Same SI unit applies. If it is the average number of arrivals per hour, then this one, the mean must indicate the average number that could be served per hour. Okay? Therefore, if it's given in any form, you need to divide by 60 to get the other one to be per hour. Then the average number of customers or units in the system is derived with L. Ne? The number of customers in the system is derived by L. Ne? Then, I don't want us to write down these formulas because I requested you to either download them or to print them. But let's rather download then so that we can move. The average time a customer spends in the system is W. Now, how long are you kept in the system? That's your W. Yeah? How long are you kept in the system? Now, it goes on to LQ, which is the number of customers in the queue. There's a system and there's a queue. Yeah? When you are waiting for your quota to be served, you are on the system. When you are waiting to be attended to by the quota maker, you are on the queue. Then the average time a customer spends waiting on the queue. Now we're looking at the average time a customer spends waiting on the queue. Then we have the utilization factor, né? Whereby P is a Greek lowercase 2 rho. That is the probability that the service facility is being used. Then P0 is a opposite of that, which is the probability that there won't be any customer in their system. And then the probability that the number of customers in the system is greater than K. Ne? So this one, let's say you had, as you can let's read here, the number of customers in the system. So you need to know how many customers are in the system. Then you are going to do this. You're starting with 0. You keep on changing this value here. 0, 1, 2, 3 until you satisfy the number of customers. That is going to give you the percentage. You're gonna get it as a percentage basically. All right. So now we're going to the first example. So Arnold's muffler shop, ne? Case. So we might not know what is a muffler. First of all, this is a muffler. A muffler is a device that reduces the noise and emissions from a vehicle engine. It's located at the bottom rear of a car and is part of the exhaust system. Bafana the boys, this is what they remove first when they find the pole so that they can attract you ladies. Agree you like the Vorpa sound? They remove all sorts of these things that are designed to control emissions and to lower the noise level of the engine so that they can seem as if they are cool, but they are damaging the car, and immediately that car has lost its warranty. You need to understand that the moment you make funny car design, your car loses warranty instantly. So, and also keeping in mind, this is the one of the things that they steal a lot in America. So they call it it's part of the catalytic converter. So it has precious metals in it, and it's in high demand in the USA. So they steal it like they are stealing polo lights here in South Africa, but they're stealing this component. Okay. So now we have we now apply these formulas to the case of Arnold muffler shop in the New Orleans. Arnold's mechanic Reid Blank. The mechanic now, the mechanic is able to install new mufflers at the average rate of 3 per hour. So this is how long this is the service rate, 3 per hour, and then or about 1 every 20 minutes. Customers needing this service arrive at the shop on average of, then the customers arrive at the average of 2 cars per hour. In other words, Arnold, the shop owner, studied queuing models in an MBA program and feels that all 7 of the conditions for single channel, so this is for a single channel. A channel represents your manpower. How many entities are you utilizing? Actually, how many resources are you utilizing? It could be machines, it could be human beings, and so on. So the formulas that we are currently going to apply, they only apply to one channel, meaning one equipment at a time. So the model are met. Okay, the single channel model are met. He proceeds and calculates the number, the numerical values of the preceding operating characteristics. Okay, so I'm going to just write show you here. Then we go on our formula sheet. We look for the first formula. We want to know the average number of customers in the system. It's derived by L. That's number 1. You are going to be told, I won't say to you calculate the characteristics of something. You are going to be told what is it that you must calculate. So you have L, it's equals to that. Okay, for the sake of you guys not having your own formulas, I will rather write them again and again. So we have this. Then where arrival, the rate of arrival is 2, then the rate of service is 3 minus 2 equals 2. Do you see that 3 minus 2 is 1? Then 2 over 1 is 2. Per hour. Right. Then number 2, based on the formula sheet, you have W, the time spent in the system, which is 1 over minus that equals to 1 over 3 minus 2 equals 2. So the time spent now in the system is going to be 3 minus 2, it's 1. 1 over 1, it's 1. Okay, I need to confirm the SI unit for this, whether it will say it's 1 car per hour or 1 hour per car. So we'll check it out because we still need to check our answers if they're correct. Then LQ on the Q. Now you're measuring on the Q, which is square of this, né? And then we have the service rate minus the arrival rate equals to, this is 2 squared over 3, 3 minus 2, this is 1, right? So now that is more like 4 over 3. This is more like 4 over 3. You can leave it like this as a fraction. This is one chapter that fractions are more recommended than your normal decimal numbers. Ne? Fractions are more recommended than your this is 4/3. I need to just confirm it. Quick. 3 minus 2 is 1, obviously, okay? And then nowadays you need to make sure, if you don't make sure, you'll be in trouble. 4 over 3. Okay, just 133. All right. Okay, it's fine. Then you are moving right along, which is you are going to WQ, the average time waiting on the queue. I think management like this. These are the waiting time on the queue. They like it and they always go for improving it. So that's why you find that the queues at ShopRite, at Pick n Pay, at the are slightly different, because the queue system is very important that you deploy. Do you want customers to randomly stand on different queues, or do you want them to stand in one queue? Do you understand? So that's where it comes from. ShopRite normally prefers customers standing on random queues, and then Macro prefers customers using one queue, so that you open the tills and then customers could be distributed into those queues. Unlike, do you know that if you have 10 tellers, if you are on teller number 1, you hardly see if teller number 10 is available or not. And I don't know what system do they use in these shops. They will open teller number 1 and teller number 10. So basically it depends which side you are coming from. You might be lucky to see, or if you are coming from the 10th one, the 10th one is available. But you don't know whether teller number 1 is open or not. Unlike that system of one queue, you are always going to utilize all of them. So that's why utilization is one of the calculations that you need to do. And you'll see even here they do focus on utilization. Okay, so now the time spent on the queue, even in the banking system, they've changed from having a financial service person, having a person who deals with bond, separate from the person who's a financial advisor, a person of loans, a person of car loans and stuff like that. They trained one person who does everything. So the moment you are sent to a person in a bank these days, I don't know which banks you're banking with, but I know it might differ per bank. Then you'll go to one aspect of a person who can sell you a new gold card and give you a loan, give you a home loan, give you a car loan, give you financial advice, and give you everything that you can think about that is in the financial sector. And that's why you must learn to say no. You will thank me later. You'll remember this words of mine. Or I said you must say no. Do not buy because of they are selling it to your face. You must always go home and think. Are we clear? But you, when you see a person twang with English, you think that that person is trying to save you. No one who speaks English is trying to save you except me. So now, this is 3 over 3 minus 2. So that is 2 over 3. Equals to 2 over 3. Okay? Then, I said leaving them as a fraction is not a crime. No? Now we want to know the probability, which is the utilization factor. The utilization factor is going to be like that. Then it's 2 over 3. I get 2 over 3. This one is the only one that you can multiply by 100 to see the utilization, because utilization means that how effective are you using your resources. Then it's going to be 67.7. 2 over 3. 66. See, I'm making a mistake. So that's your utilization. And then you want to know what is the probability opposite of that there won't be any car. So you say minus 1 minus that. So then the probability of that there won't be any car, it's 1 minus 2 over 3, which is 0.33, which is also equivalent to 33%. All right. Then now we move to the next step, which is number 7. Number 7 says probability of more than k units in the system. Okay, k units in the system. So here you will end depending on the units on the system. The units on the system determines where you must stop, which is, let's look at the L value. Say it says 2, so I would stop at 2, even though they stopped at 3. So I want to carefully decide how they are doing this one, because of it will have a long calculations which I'm not ready to say you must do in a test. So let's do this like this. Say Pn k equals 2, so that over this, and k plus 1. So what does it translate? It translates to I must make this one to be a little bit thicker. Yeah, and then 2 over 3, and then this is 0 plus 1. So we start at 0 plus 1, and we have 2 over 3, then 0 plus 1, then our value is, so when we are saying k is it's at 0, we have 2 over 3, then which is 66%. Then now you repeat it, 2 over 3, you put 1 in now, this is 1 equals 2. You just come and change that 1, then it becomes 4 over 9, 4 over 9, and you carry on again, 2 over 3, 2 plus 1 equals to 16/81, which I would rather convert it so that I can see it. 1975. Okay, 0.1975. I want to see where did they stop. 19. Yeah, they stopped here. So now, yes. Okay, I'm getting. Okay, I placed 3. Supposed to be 2. Sorry, you're correct. I placed the wrong one. Sorry for that. It's 8/27, which is 0.296. Okay, then the last one is 2/3. 3 plus 1 equals 2. So 3. 1975. So now 1975 multiplied by 100, you get. I want us to agree this, because not everything that we ourselves prepare to teach will come out our offices understanding exactly what they're trying to do. Understand? We're not Albert Einstein every time. So now, in this case, there were 3 items being serviced at a time. Again, so this 3 to me determines this 3 here. So they want to know that when you are servicing 3 items, what is the probability that there will be a certain number of vehicles. So now it says this implies that there is a 19.8% chance that more than 3 cars are in the system. Understand? That more than 3 cars are in the system. There's a 19% chance. And then also at 0, meaning that there could be a probability of 67% that there are 0 cars. This is what the formula suggests basically. So we will limit it at 3 based on the number of vehicles in the system. So I would rather say number of vehicles being serviced, which is this one. We'll see. I will confirm this when we're doing problems. Remember, sometimes book examples tend to be a little bit ambiguous until you do the book problems. Then that's when you are able to confirm. That we'll be able to do when we get there. I didn't have that time to say I would do it at home, because I needed to make sure that every single calculation I am able to execute it. Okay, now we have cost formulas. Obviously, when you wait in the queue, there is a cost. There is a cost. Remember that. Waiting in the queue, there's a cost, and you might easily lose a customer. They might go for another competitor. So you can't keep them forever on the queue. So you need to know how much you are losing. So let us consider the same example, whereby the customers. So basically, when your customers are waiting online, per hour you are losing you are losing $50. Arnold estimates that the cost of customers waiting time in terms of customer dissatisfaction and lost goodwill is $50 per hour spent in the waiting line, ne? Spent in waiting in the queue, ne? This is what it means. Waiting online, it's the queue, meaning that WQ. So it kind of derives which values we're supposed to use going forward. I might have forgotten to confirm my answers here. Let me just quickly confirm them. No, but this seem to be correct. 4/3, 2/3. Yep, they're fine. All right, so we carry on. So now we are now losing customers. So after customers are actually being serviced on the rack, customers don't seem to mind waiting, because on the average a car has the cars wait for 2/3 hour. Okay, there are actually 2/3 cars per hour, and there are approximately 16 cars serviced per day, right? 16 cars serviced per day, and then 2 per hour times 8 working hours. So you need to keep that in mind. So you have 8 hours, you have 2 cars that are being serviced per hour, that leads to 16 cars serviced per day, ne? So that is also important. All this information is important. Okay, then you have your 16 cars serviced per day. And then the total number of hours customers spend for mufflers to be installed each day is 2/3 times 16, which is that. So but that is not what we're going to consider now, because we have our own formulas. So there's a section here when they say this is how much the company spent on Mr. Blank, ne? This is how much the customer spent on Mr. Blank. Then if you go, you will see this formula, the total cost, the total service cost plus the total waiting cost, and you have this as your cost. Then you also have this one when you say somebody is waiting on the queue. This is the formula for waiting in the queue. So we're going to consider the one of waiting in the queue. So now you need to know that your WQ is equals to, you can go up and take your WQ there. Where's your WQ? You see there, 2/3. Your WQ is 2/3. All right, and then your rate at which your cars are coming in is 2. Okay, and then the total working hours per day, that is 8. The cost of waiting on the queue is 50. The cost spent on which is the service cost, is 15. Then the formula is presented in this way. Total cost is equals to M, the number of channels that we're dealing with, which is one machine at a time, service cost, plus the rate at which cars are coming, and then the cost of waiting, and the WQ. We must start with WQ, which is not a problem. Then now there's only one machine being utilized, which cost us, or one person which cost us $15 per hour. How many hours are being worked out? They are 8, ne? For 8 hours. Plus we have 2 cars that are coming at the time. We have the cost of waiting, which is 50, times how long are you waiting? You're waiting for 2 over 3, times how long are you working? You're working for 8 hours. TC is equals to 15 times 8 plus 2 times 50 times 2 over 3 times 8. Then you get your answer as 653.33. Okay, then there's this time that they talk about here, which is not part of the question. It's just what it says the total number of hours that customers spend waiting for a muffler. So your waiting is 2 over 3 multiplied by 16 cars. Oh, so all cars will wait this amount. Okay, so I want to see, because I think it might affect us as time goes on, which is gonna be 10 or 6 7 hours. So in total, cars have spent 10 hours, whereby each was delayed 2 over 3. Ne? Each car was delayed 2 over 3, meaning 0.67 hours. So, but in total now they amount to 10 because there are 16 cars. Okay? Then obviously our answer there is correct. Then we move right along to say, okay, this one is very interesting. So now comes a decision. Arnold finds out through the muffler business grapevine that the Rusty Muffler, a crosstown competitor, employs a mechanic named Jimmy Smith who can efficiently install new muffler at the rate of 4, meaning that it's no longer at the rate of 3, it's now at the rate of 4. And then Larry Arnold Smith contact Smith as to his interest in switching employers. Smith says that he will consider leaving the Rusty Muffler, but only if he were paid $20 per hour. So you know that the new service cost is $20 per hour. That doesn't change the rate of cars that are coming into the system. Okay? Then now Arnold, being a crafty businessman, decides that it may be worth a while to fire Blank and replace him with the speedier but more expensive Smith. So now we want to do the cost, but we have to start afresh everything. As you can see here, the book suggested that they do these calculations again. This is a self-study. You are going to recompute those calculations that we did from scratch. You're going to recalculate those calculations we did from scratch. Then now what I'm going to focus on, the cost, so that we can quickly compare the cost. All right? So when we're comparing the cost, we need to look for WQ. Then let me go back to my formulas. WQ is this over, okay, minus that, which is equals to the rate of 2, 4, 4 minus 1, which is equals to 2, 4, 4 minus, no, 4 minus 2. Then answer is 1 over 4. Then we now know that our answer for waiting is, and then we need to do the total cost. So we know that it's 1 multiplied by your service cost. Now it's 20 working for 8 hours plus your rate at which cars are coming, multiplied by the time spent, multiplied by 50, multiplied by 8 hours. So now our answer is going to be 1 times 20 times 8 plus 2 times 1 over 4 times 50 times 8. Then the new answer is 360. Equals to 360. So the total cost has went down. So, but you are interested to know by how much did it go down. So the cost difference is that one of 653 minus 360. So if he opt for this, he would save, I think it's 0.33, something like that. Answer. He will save around about 293. He will save around about 293. Okay. So do not forget the next section was a self-study, you DIY for the sake of time. So as you can see here, we are saving 293. All right. So now we have these formulas. They are starting to get keep that in mind. Understand? So you see here, this is a sum of this, then meaning that you do them until you reach n equals to n minus 1. So you're starting from 0. So you're gonna do for 0 this formula here, you do it for 0 plus you do it for m minus 1. Then so if m is 3, so it's going to be 3 minus 1, which is 2. So you want to do this until 2, and then you sum them up before you add them to this. So very interesting formula, this one. But let's then, because of we are no longer dealing with one, we're basically starting afresh. We're no longer dealing with one channel. We are now dealing with multiple customers that are coming. Multiple machinery, not one machine, or multiple employees. Right. So I need to erase everything that I wrote here. Guys, as soon as you pick up something that is a mistake that we are all doing, believing that it's right, you let me know so that we can address it before our test. Unlike we find ourselves going to the test, then I thought I did erase here, but what can I do? My waking rate current is 24 hours, so I work non-stop. So now the only difference is that this guy wants to save the cost, ne? I wants to save the cost by exploring a third option. So a third option goes like this. A third option is now explored. Arnold finds that the minimal after cost, he can open a second garage bay in which mufflers can be installed. Instead of firing his first mechanic blank, he would hire a second worker. Ne? So now we have 2 workers that are doing the same job. The new mechanic will be expected to install mufflers at the same rate as blank, about 3 per hour. Customers who will still arrive at the same, they will still arrive at the same rate, okay, will wait in a single line until one of the 2 mechanics is free. Okay, now we need to explore that formula that I've just shown you now. I'm going to go up so that I can be able to write comfortably. So the formula is derived in this way. We have it as, I'll go somewhere here and start writing here. I need enough space. Okay, that is number 1. I will never change the sequence of the formulas, but I'll remove a lot of explanations for the self-explanatory. I cannot give you with explanations. And then, yeah, so I'll remove the explanation, but the sequence, I'll leave it the same because they kind of guide you. Okay? You know, we start with that, followed by that, by that. And also, whenever I ask you, I want you to execute them as they are. Okay? So now we have P0, it's equals to, then, oh, computer, behave. This one doesn't allow that. You see now, when I'm at home, my PC, when I make a line and I stop, it changes, like it makes a straight line, but it's fine. I've discovered a better way. I'll do this, make a nice straight line for myself. Okay, then one, go to the corner there, it says n it's equals to m minus 1. This is where we stop doing the calculations. Then we're starting at n is equals to 0. Then 1 n exclamation mark, open bracket, and then the rate of which cars are coming and then rate at which they are being serviced over n, close bracket, plus 1 over the number of channels that, and then m. M that I'm consuming a lot of time writing the formulas down, but it means that because of I told you again, on Friday I won't write any formula. I'll be looking at it and punching the information that is required. But in a test, write all the formulas because of there are marks for formulas. Okay? One. Then now we are starting 1 over n, we're starting at 0 exclamation mark, ne? And then open bracket, 2 over 3 and then 0. All right, then can someone put another bracket here, plus open bracket 1 over 1 exclamation mark, 2 over 3, then 1. This is where we end, close. You see that? That's where we end. If we needed to go to 2, we'd go to 2. I'll make it a point that I make life easy. So n is equals to m minus 1, which is equals to 2 minus 1 equals to 1. So n is equals to 1 here, the one that we're supposed to end with. So this is our 1 there. All right, plus 1 over 2 exclamation mark, 2 over 3, and then m is 2, and then 2 times 3, 2 times 3 minus 2. So that's how we are getting it. So we'll start by solving the values under, because a calculator sometimes doesn't have enough memory to write all these things down. So you start solving everything under there, né? Under there. So we're going to have this as so 1. Come on, come 1. Then I'm solving everything under. I'll start with those two. So it's going to be 1 over 0 exclamation, then open bracket, 2 over 3, then x to the exponential to the exponential 0. Okay, then plus I can somewhere explain. Yeah, I like it like this so that you can see that this one alone I found 1 on it, né? Plus now I'm doing this. So I just go to my calculator and I just change the values. I just change my values there. And then I have this as 2 over 3. So you can just close it in a bracket plus. Then now we are doing this part. You can just compute it, all of it. So it's 1 over 2 exclamation mark, open bracket, 2 over 3, close bracket, 2. That is m again, yeah, times. You can just put it in a bracket, 2 times 3. Okay, and then 2 times 3 minus 2. Okay, I want a bigger bracket there. That's wrong. Two times 3 minus 2. Oh, there's a bracket there. All right, it's 1 over 3. 1 over 3. So this wasn't supposed to be this long. And 1 over 3. Then 1 plus 1 over 2 plus 1 over 3. It's equals to 0, 5, 5, 5. But I'm not convinced that this is correct. I need to just verify quickly. Okay, it says 0 is 5, but why it says 5, 5 here? Okay, I need to redo again. Where did I make a mistake? It's easy to make a mistake, keep that in mind in these formulas. Okay, 1 over that 0 and okay, 1 that, okay, plus 2 that, okay, m, then m 2 times 3 minus. Okay, so what could have went wrong? Uh, 1 over 1 exclamation, 2 over 3 to the power 1, 2 over 3. Okay, perfect. Then 1 over 2 exclamation, 2 over 3, get this as a 2, open bracket, 2 times 3, 2 times 3 minus 2. It's 1 over 3. Okay, so 1 plus 2 over 3 plus 1 over 3. Yeah, I don't know what happened, but now I'm finding the correct answer without changing anything, which is 1 over 2. So it kind of forces me to accept uh, computational errors that students can do. Ne? It's forcing me to accept computational errors, so I must put a what you call it, a tolerance in the answers students can give me, right? Then, but this is the only difficult one. The rest are quite straightforward. But I need a 1 minute personal break. I am coming now. I won't pause because I might damage the recording. I'm coming now. No, just a second. Ah. Right. So I'm just going to confirm my recording. It looks like it's still continuing. So we also need to continue. Whew. All right. Then the second formula goes like this. P. Okay. L, in fact. L is equals to the rate of arrival, the rate of cars serviced, open bracket, the rate of arrivals over the rate of being serviced, to the power m, then open bracket, m minus 1 exclamation, m multiplied by your rate of service, then 2, okay, multiplied by p0 plus this, okay. Then the nice thing is we already found the p value, and therefore here we have what, 2 multiplied by 3 of bracket 2 over 3, no, yeah, 2 over 3 to the power 2, and we have 2 minus 1 exclamation, and 2 times 3 minus 2 to the power 2, okay. And then we have 1 over 2 there as your probability at 0. Okay, I'm writing the correct one. I thought I was writing opposite of what I'm thinking. Then plus 2 over 3. So this one, the calculator can handle it. So you can just move it straight. It's going to be 2 times 3, open bracket, 2 over 3, square like that. Then 2 minus 1, the exclamation mark, bracket, 2 times 3 minus 2 squared. Then times 1 over 2, and then plus 2 over 3, and the value is 3 over 4. The value is 3 over 4, which is quarter. 3 over 4, 3 quarter. We call it a 3 quarter in the language of tools and so on and so on. So then after that, the nice thing is the following one, it's LQ. No, it's not LQ, it's W, which is an equivalent of L over that. You see that? Then we have 3 over 2 over 2. You know that your answer it's more like 0.75 divided by 2. Divided by 2. Okay. Which is going to give you a fraction of 3 over 8 and 0.375. Okay, we move right along. We go to is it LQ equals to L minus this, the rate. Okay, there. Then what is our L? Our L is 3 over 2 minus 2 over 3 equals to 3 over 2 minus 2 over 3. Then we have 5 over 6. 5 over 6. You'll convert it when you want to use it again. So now LQ, WQ now. WQ equals to, we have LQ already again. LQ over that, and then so the number of LQ divided by 2, which is 5 over 6 divided by 2, which is 5 over 12. Okay, 5 over 12, and then we're gonna need 5 over 12 when we're doing our weighting cost. Okay, then we have the probability now. P is equals to this over M that, then 2 over, and I'm going to ask a very ambiguous question here. If we are having this which is 3, this one, we need a family limiting for it. I'm wondering what's going to happen, because if we're saying probability is this 2 over 2 times 3, if we're saying your probability is this, and then you then say P0, there's a formula of P0 minus that. So what will happen if we can try to find P0 here? I want to see. So this is going to be 1 minus this answer 2 over 3. Let's not make sure, because our probability at 0 it was 2. 1 over 2, it's not gonna work. It's not the 1. Okay, so you are forced to recalculate the whole probability, the initial one. So obviously there's a cost. There must be a cost. The cost is going to be measured like this: MCS plus your rate at which items are arriving, Q times CW, then 2 times what is your normal rate, which is 15, you still remember it, times 8 plus 2 times 5 over 12 times 50 times 8. I want to confirm my 5 over 6 divided by 2. Five divided by 12 equals to 0.41. Okay, my answer for, oh yeah, it's correct. Ooh, lucky me. 0.41. Yeah, WQ is correct. Okay, perfect. So now this is how we were gonna get the total cost for using 2 people. So which is going to be 2 times 15 times 8 plus 2 times 5 over 12 times 50 times 8. Then the cost becomes 573. Cost to 573. It still cost, it cost less than working with that one guy, and it cost more than working with the skilled labor. Remember, it was 360 on the skilled labor, and then it was 5 something, I think it was 600, ne? 653 for the skilled, for one unskilled labor. 653, something like that. You can just go up to confirm it. 653. So unskilled labor, 2 unskilled laborers, 1 skilled labor. So you do the math. The best is to take the skilled labor. Right? And now this one is a very interesting one, whereby for this method, we are measuring things that are coming to you at a constant service time. So you are having a constant service time. So you have current, and then you have future. Then they are saying to you that trucks arrive to unload these materials for recycling. Currently wait average of 15 minutes before loading. So waiting time is 15 minutes before loading. So 15 divided by 60 is one. So current, you wait 1.5 hours, 1/4 hours, so this is the waiting period. And then the cost of waiting is times 60. You are losing 60 when you are waiting on that queue, which now per trip is going to be times 60. So you are losing $15 per trip that you make, because every trip you wait this amount of time. So you are waiting for 15 there. So now they are saying that a new automated compactor can be purchased that will process truck loads at a constant rate of 12 trucks per hour. Okay, 12 trucks per hour. And then trucks arrive according to Poisson distribution at an average rate of 8. Okay, so cost arrive at the average thingy of 8, and then the ones that are being serviced is 12, and then arrival is cost to 8. So 12 trucks per hour, 8 per hour. Okay, which is good. Then we now go to the formula. We are looking for WQ equals to, that's your formula there, rate of arrival 2 times your service time minus the rate of arrival, which is going to becomes 2 over 2 times 12 minus 8. So this one is 8 actually. Then 8 over 2 times 12, open bracket, 12 minus 8. So we are having this as 1 over 12. This is just 1 over 12 of what? Hours waiting in the queue. So waiting in the queue for 12 hours, we will multiply it by 60, so then you'll get per trip. So 1 over 12 multiplied by 60, then you have times 60, you have 5. Are you sure? 5. Okay, 5 rand per trip. So now we had a 10 there, now we have a 5. So when you are comparing, it's going to be, okay, if you had the original system of 15 rand per trip minus 5 rand per trip, it's equals to 10 rand per trip now, the amount that you're going to save. But we have a cost. They say it's amortized rate of $3 per, then you minus that cost of 3. Then now you are left with 7. This is how much you are going to save, 7 per trip. You see, constant rate is very nice. We're done with it. Then we're moving to the other one, the finite population. The finite population. This one kept me awake the whole night. I couldn't solve it. Even AI couldn't solve it. But I woke up and did it in less than 30 minutes. So now, on this one, we have each of the 5 high speed, ne? N, guys, N is equals to 5 printers. And then you need to repair after 20 hours, ne? So the rate at which it's 20 every 20 hours. Every 20 hours a printer comes. A printer comes for service, ne? But that is 20 hours per printer. We want a printer per hours. Therefore, you do inverse of that. Then it becomes, the rate becomes 1 over 20. Unit per hour. I change it to unit per hour. And then the service now, how long does it take for this guy to service? Forgive me guys for erasing here. I had to practice. I was still practicing when the water on my shower was open. Can you imagine that? So I was like, hey, this thing I need to figure it out before I go to class. The students will say I'm a muhu if I don't. So now we have what? The service time. Where is the service time? It's of average of 2 hours per printer. So we obviously that is 2 hours per printer, your service rate. 2 hours per printer. That's not what you're looking for. You're looking for printer per hour. So that is going to be 2 over 1 over 2 also. So we do the inverse of this. So now remember when we started this, we wanted to make sure everything is in unit per hour. If you find hour per unit, you do the inverse. Keep that in mind. It's recorded also. So in this book, the reason why I spent the entire night doing this exercise, they say, they give you the answers like that, and then they say, we leave these calculations for you to confirm that the answer is indeed 0.564. And this is where it got interesting. So if you look at the formula, so if you look at that formula, it says to you, where is it? Where's the formula? Hey, it's at the back. I couldn't press it. Where at the back, guys? That one, come, guys. Come around. And then the first one goes like this. 1 over sum of, you see n, this is where you end. So you are, everything's determined by n, and n is equals to 5. And then n, small n is 0. Then you have n that, ne? And n minus n like this, exclamation, ne? Then you have this over that. Then you have n. You see? Then now we know that we're ending at 5. That's our, based on the n here. You must end at 5, starting at 0. So now we're gonna write it only once. This thing from there, you change the values on the calculator, because you obviously you will write the whole thing the entire day. So now this whole equation is supposed to be done over a long stretch, basically. So it's going to be 1, that n it's 5 over 5 minus 0 bracket exclamation mark. Ne? Put the 5 as exclamation mark also. Put this thing into one big bracket. You can test without the bracket and you tell me what you get. Then 2 over, we're no longer dealing with 2 and 3. We're dealing with these two guys here. This one is equals to 0.5, and then this one is equals to 1 over 20, which is 0.05. 0.05. It's a rate at which items are arriving to you. Then zero point 0.05 over 0.5. Then you have this, then you have 0. You have plus, because this thing doesn't end here, it repeats itself until 5. It repeats itself until 5. So what will happen is, it's plus until n. Again, then now we're gonna do this instead. 1 not gonna make it to be too long like these other ones. Then I place it there, then I come here. Take your calculator. You are only measuring stuff that are under there. Then you have 5 exclamation open bracket, 5 minus 0, outside is an exclamation, and then you have 0 over 0, 0.05 and 0.5. Then you have that as your 0 there, sharp. Then your answer is 1. Your answer is 1. Plus, we are repeating this with 1 here, with 1 there. So to edit that, you just go to back to your calculator, then you edit. Then I have a half. 1 over 2 plus. I edit this 2, then I come and edit this 2. Then I have 1 over 5. 1 over 5 plus. I have 3. I come and edit and I have 3. Then that is 3 over 50. 3 over 50 plus. Then I edit that 4 and I edit this to become 4 also. Then I have 3 over 250. Okay. For some reason, it's continuing. Plus. Then the last one, which is 5 and 5, which is 3 over 2500. Okay, then you sum all of them under there. We have 1 plus 1 over 2 plus 1 over 5 plus 3 over 550 plus 3 over 250 plus 3 over 2500, and the value you are getting is 0.564, which is the same as the value that they got here. You see how we do it? I wouldn't mind making you write all those things in a test with your anxiety. I wouldn't do that. You follow this procedure. If you decide to write all of them, it's still okay. Ne? If you write the entire thing, it's still okay. Me, I won't argue with you. The n, I'll reduce it. Should I test this? I don't know what I'm going to test. The n, I'll reduce it. 5 is too much. Okay. Nevertheless, we have the second formula, LQ. Then we have LQ. Others are straightforward. That's one thing I like. Only the first one is always a disaster. N minus this. Okay. You have formula sheets. No. Cannot waste time. I'm tired. I can feel it. I have another class. So 5 minus open bracket. Remind me. 0.05 plus 0.5 over 0.05 close bracket 1 minus 0.564. Then go straight to your calculator, apply the formula number 2. 5 minus 0.05 plus 0.5 over 0.05, okay, then 1 minus 0.564, and then the answer is 0.204. Okay, moving right along, we have L. It's equals to the value that we just got, 204 minus, no, actually plus 1 minus 0.564, which you are getting now. This answer plus 1 minus 0.564. Then the value is 0.64. Then WQ is equals to LQ 0. Where is LQ? LQ is this one. 0.204 over 5 minus L, 0.64. Outside is 0.05 equals to. Then we have 0.204 over 5 minus 0.0, no, 0.64, and then times 0.05. Then you have your answer as a 0.936. Then the n units, I don't remember if they calculated it. So W now, W it's equals to our answer that we just got now, 36. You see the amount of dynamo effect that is here. it's just too much, meaning that you must practice, otherwise you're gonna lose marks. uh, 0 and I think this one is 0.5, you know? Yeah. Okay, which is equals to my answer plus 1 over 0.5. Then my final answer is 2.935. Okay, I'll quickly verify that. And luckily they didn't look for that other one, the PN. They didn't look for it. I don't look for it also. So my W is 2.9. 2.9. That's 2.9. Okay, good. And then my WQ is 0.9. That's my 0.91. Okay, and 0.64, it's my L. 0.64, it's my L. Okay, everything else seems correct. And then my LQ is 0.2. We are on business. We found all of them. And after that, that's your formula sheet. So it means that we are calling it a day. And I will do the problems on Friday. So this Friday we are coming in. This announcement in the group. I'll also announce on the side. This Friday we are meeting online. 8 o'clock as usual. Then next week, Friday, space bar, we are writing the test. One chart. One chart. Then, yeah. Then guys, I'll give you the bad news after the after recess. We do have the bad news. No, we still don't have the exam. But we have a very dangerous condition. Class means that all assessments need to be passed. So we have that bottleneck now. So we might be forced to write test one, those who didn't get a 50. We might be forced, and it's going to be kept, of course. But I still need to discuss. We lost 3 weeks, so I'm still in discussion. But the policy, it's unshaken. It doesn't mix its weights. It says it requires everyone to pass for every assessment. But I'm going to Prof right now as we speak. I'm going to get a final answer from him,